Alright, so in this problem we are asked to find the surface area of the composite solid shown, and the composite solid is made up of a smaller cone on the top and a larger cone on the bottom. So in order to find the total surface area of the composite solid, we're going to want to add up the top cone surface area with the bottom cone surface area, and that'll give us our final answer. So the only formula we need in this problem is the surface area formula for a cone, and that is surface area is equal to pi r squared plus pi r L, where r stands for the radius and L stands for the slant height. So we're going to start off with the top cone, and we're going to write out the formula. Surface area is equal to pi r squared plus pi r L, and it's important to remember in this problem that you can think of surface area as if you were to spray paint the composite solid, where would the spray paint touch? So if you look at the composite solid, you do not need to include the base of the top cone because spray paint would not touch the base. So we only need pi r L. In place of r, we're going to put a 3. And then before we can plug in a number for L, we need to first calculate the slant height. And we're going to do that using Pythagorean theorem. So off to the side, we're going to calculate 3 squared, which is the radius, plus 4 squared, which is the height of the top cone, and that's set equal to L squared. 3 squared is 9, plus 4 squared, which is 16, is set equal to L squared. 9 plus 16 is 25. 25 is equal to L squared, and then lastly, square root both sides, and L, which is your slant height, is equal to 5. So now you're able to plug that 5 into your formula, and we have pi times 3 times 5, and we're going to multiply our two numbers, 3 times 5 to get 15, and we're going to leave our answer for now as 15 pi yards squared, and that is the surface area of the top part of the composite solid. So now we need to consider the bottom cone of the composite solid, and we're going to find that using the same set of steps that we just used to find the top portion. So we're going to use our formula. Surface area is equal to pi r squared plus pi r L, and again we do not have to include the base of that bottom cone, so we're going to cross that out of our formula and we only have to use pi r L. In place of r, it's a 3 again, and then we're also going to have to use Pythagorean theorem to calculate our slant height. So we're going to use 3 for the radius as well as the 8 for the height, and when we set those up into Pythagorean theorem, we will figure out our slant height. So 3 squared plus 8 squared is equal to L squared. 3 squared is 9. Add that to 8 squared, which is 64, set it equal to L squared. When you add up 9 plus 64, you get 73. Set equal to L squared, and then lastly square root both sides to get a slant height of 8.54. We can now take that slant height and we can plug it in place of L into our formula. So we have pi times 3 times 8.54, and then we are going to multiply the 3 and the 8.54 to get 25.62 pi yards squared for the surface area of the bottom portion of the composite solid. So now to find our total surface area of the composite solid, we're going to add up the top portion. So that top cone, what we found that to be, plus the bottom cone, what we found that to be. So it's 15 pi plus 25.62 pi. Add up the coefficients. So 15 plus 25.62 is equal to 40.62 pi, and then your last step is to multiply the 40.62 times pi to get a total and final answer of 127.61 yards squared, and that is the surface area of the composite solid shown.